Algebra 2. Right now we are doing our notes for 0.2, difference of perfect squares. So make sure you have your packets out and follow along with me while I go through these notes. We're going to start with two review questions that we just went over in 0.1, and that is factoring out a GCF. So in order to factor out a GCF, first we need to find the GCF. So that's going to be the biggest number that goes into all of your numbers. So remember my advice, look at the smallest coefficient and see if that goes into the other ones. So in this case, our smallest coefficient is 3. And you'll ask yourself, well, can I divide 12 by 3? And can I divide 9 by 3? And if your answer is yes, that means that 3 is correct. That is the biggest number that goes into all of your numbers. And then you need to pick the variable. So if all of your terms have the same letter, then you need to pick the letter with the smallest exponent. So in this case, it is this guy right here, the 2, it's m squared. So my GCF is 3m squared. And in order to factor out m squared, 3m squared, you need to divide by it because factoring is division. So 3 divided by 3 is 1. And then m to the 4th divided by m squared. We subtract our exponents when we divide. So I have m, and then I subtract 4 minus 2. 4 minus 2 is 2. So that's 1m squared. Bring down the plus sign. 12 divided by 3 is 4. And then m to the 3rd divided by m squared. Again, you're subtracting. 3 minus 2 is 1. So that's m to the 1st. Minus 9 divided by 3 is 3. And m squared divided by m squared cancels out. So we have our answer here. 3m squared times 1m squared plus 4m to the 1st minus 3. For number 2, I find my GCF. So the biggest number that goes into 4 and 2 is 2. So I'm going to divide by 2. And then they both have the same letter, so I just need to pick the one with the smaller exponent. So in that case, that would be x to the imaginary first power. So my GCF is x to the imaginary 1. So now I just need to divide by x to the first power. So 4 divided by 2 is 2. X squared divided by x to the 1st. I subtract my exponents, so 2 minus 1 is 1. Bring down the plus sign. 2 divided by 2 is 1. And actually x to the 1st divided by x to the 1st, it's the same thing, it cancels out. You could have said 2x divided by 2x is something divided by itself. So you could have canceled it all out, but you do still need that 1 as the placeholder because technically something divided by itself always equals 1. So we have our answer. So right now, today on Notes 0.2, we are going to relearn how to factor when we have a difference of perfect squares. So we've learned this back in Algebra 1, so hopefully it's not forgotten by you. Let's just fill in these blanks and then we'll get practicing and we'll fly through it. So sometimes if you have two terms, we use DOPS when you have two terms. It can be factored using a special rule called DOPS. Now DOPS stands for difference of perfect squares. We can use DOPS when there are two terms separated by a minus sign. It's called DOPS because of the word difference. Difference means subtraction. So that's why we need a minus sign. So it's two terms separated by a minus sign, and all numbers and variables are perfect squares. So a perfect square is a number times itself. So I'm just going to list the first, we'll do the first 12 perfect squares. So 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16, and so on. You just multiply the numbers by itself and you get all of your perfect squares. So like 7 times 7 is 49. 8 times 8 is 64. 9 times 9 is 81. 10 times 10 is 100. 11 times 11 is 121, and 12 times 12 is 144, and so on. It goes on forever. For variables, in order for a variable to be a perfect square, you need to have an even exponent. So variables that are perfect squares would be x squared, x to the fourth, x to the sixth, x to the eighth, and so on. You could also have a combination of letters be perfect squares as long as they are both even. So if we have x squared y to the fourth, that's a perfect square. You could have a to the 10th, b to the 8th, and c to the second. That's a perfect square. As long as all of the exponents are even numbers, then it's a perfect square. So for those of you that had me back in Algebra 1, you'll remember how to solve these hopefully after I do a few examples. I call it break it down. You take everything in your question and we list it on the side. You don't have to do this once you get the hang of factoring DOPS, but while we're practicing, we break it down. So first up is x squared. Then I hit the minus sign. The minus sign is where we draw one long line to separate. Then I have 9. And then we break it down. So you ask yourself, what times what is x squared? Well, that's x times x. And then what times what is 9? That's 3 times 3. Once you've broken it down, we're actually going to group these up. So we put one of the x's and the 3's together and the other x and the other 3 together. And on that line goes one plus sign and one minus sign. So we end up with the answer x plus 3 times x minus 3. That is how you factor when you have DOPS. The reason you have to have one plus sign and one minus sign is because when we distribute, if we want to check our answer, I'm just going to write check. When we distribute, we need the middle to cancel. So this is going way back, double distributing. X times x is x squared. X times negative 3 is negative 3x. 3 times x is positive 3x. And 3 times negative 3 is negative 9. So in the middle here we have negative 3x plus 3x. Those cancel, giving us x squared minus 9. So that's what we needed it to equal because that was the question. That was the thing that we were supposed to factor. So DOPS always is set up this way. You always have one of the pluses and one with a minus because that's the only way to get those middle terms to cancel out so that you end up with just the two terms with the minus sign in the middle. So all of this stuff, this check, all of the stuff I wrote in pink, that's not part of our answer. That was just to check our answer. The stuff in blue is the answer. That's what we need. So let's break down number 2. So I'm going to take the question, write it out. So I have x squared, then I have the minus sign. So I'm basically drawing one giant minus sign to separate. And then I have the 16. So x times x is 16, or sorry, x times x is x squared, and 4 times 4 is 16. So I can group them up. One of them gets the plus, one of them gets the minus. It does not matter if the plus goes first or if the minus goes first. You just have to have one with a plus, so x plus 4, and the other with the minus, so x minus 4. And there's your answer. So once you get the hang of it, you can go through these super, super quick. This is supposed to say number 3 right here. Number 3, you can't factor this yet. We'll actually learn how to factor this eventually, but that's in months from now. But from what we've learned so far, this is what we call not factorable. I'm just going to put yet because we'll learn that in a few months. And the reason this is not factorable, because yes, we have perfect squares, PS for perfect square. We have a plus sign though. We need a minus sign in order to do DOPS, so this plus sign ruins everything. So we can't factor that. But number 4, we do have it set up correctly. We've got an even exponent, which means that's a perfect square. And then 25 is also a perfect square. And I have a minus sign in the middle, so I can break this down. So I have m squared, then the minus sign, and then 25. So that's m times m, and 5 times 5. Group them up. One gets a plus, one gets a minus. So that's m plus 5, m minus 5, and that's your answer. Number 5, perfect square. We've got b squared. That is a perfect square. So that's b times b. Then we have 100. That's 10 times 10. So I group them up. One gets a plus, one gets a minus. So we have b plus 10, b minus 10. And that's our answer. Number 6 is actually not factorable. And same thing, we're just going to put yet because we might be able to factor it in a few months once we've learned some more stuff. The reason it's not factorable is because I have an exponent that is not an even number. In order for there to be dots, it needs to have an even number in the exponent. So x to the third is not a perfect square because the exponent is not even. So we can't do anything with that one. All right, so on to the back, we've got 4x squared minus 25. Those are all perfect squares, so I'll break it down. First up is the 4, and then the x squared, and then the minus sign. So then I put the line and 25. A lot of people get confused when breaking it down like this. You always go in order. So first up was the 4, then the x squared, then the minus sign, and then the 25. Go in order from left to right. The minus sign is where you draw that long line to separate it. So since the x came before the minus sign in the question, my x squared needs to come above the line when I break it down. So 2 times 2 is 4. X times x is x squared. And 5 times 5 is 25. So when I group these together, remember the plus and the minus sign go on the line. So that means it's 2x plus 5 and 2x minus 5. For number 8, again, left to right. First up is 36, then the minus sign, and then y squared. You have to go in order from left to right. 36 is 6 times 6. Y squared is y times y. So I have 6 plus y, 6 minus y. And that's our answer. Number 9, 144 is a perfect square. A squared is a perfect square because it's got the even exponent. Then my minus sign, so that's where I split it up. Then 16, and then b squared. Just go in order from left to right. So 144 is 12 times 12. A squared is a times a. 16 is 4 times 4, and b squared is b times b. So I group these all together. One of them gets a plus, one of them gets a minus. So I end up with 12a plus 4b, and then 12a minus 4b. Number 10, first up is 49, then m to the fourth, then the minus sign, so that's my line, then 36, and then n squared. 49 is 7 times 7. M to the fourth is m squared times m squared. 36 is 6 times 6. And n squared is n times n. Then I group them up, put my plus, put my minus. So I have 7m squared plus 6n times 7m squared minus 6n. And that's your answer. Number 11, 81, and then the b squared, then the minus sign, and then 100. So that's 9 times 9, b times b, and 10 times 10. So that gives me 9b plus 10 times 9b minus 10. And finally, number 12, we actually have a plus sign in the middle. It needs to be minus. So this is not factorable. So we can't actually do that question. And that's it. So that is DOPS. Now you can go to homework 0.2 and do all of the questions on homework 0.2.